This video covers content from your Chapter 1, Section 7 lecture notes. In this section, we will review the concepts of exponents as well as order of operations. Exponential notation is somewhat of a shorthand for us, and it saves us time and a whole lot of writing sometimes. If we have the same number multiplied repeatedly, like 4 times 4 times 4 times 4 times 4 times 4, we can write that instead as 4 raised to the exponent of 6, or 4 to the 6th power. Notice that 4 was multiplied by itself 6 times, and so my shorthand is 4 to the 6th. The number that's being multiplied, we call that the base. So in this case, 4 is our base. The exponent is what tells us how many times that base is being used as a factor, how many times we are multiplying that base by itself. So that's our exponential notation. Let's look at some examples and simplify. Let's talk a little bit of language here. When we have 4 raised to an exponent of 3, we would say that as 4 cubed. When we have 6 raised to an exponent of 2, we would say 6 squared. Anything larger, though, we say it a little different. So 2 raised to an exponent of 6, we would just say to the 6th. So it's squared, cubed, and then 4th, 5th, 6th, and so on. Let's simplify part A, and I will leave B and C for you to work on. In part A, we have 4 raised to an exponent of 3, or 4 cubed. That is 4 times 4 times 4. 4 times 4 is 16, times another 4 is 64. So 4 cubed is 64. Let's jog over to example 2. Here we're also going to simplify, but now we have some fractions and some negatives. Now, first of all, I do see some typos I need to fix. This should be 1 over 8 to the 3rd to match up with your notes. And F and G, those should both be raised to the 4th. That should match your notes a little better. If I have 1 over 8 to the 3rd power, that means I need to do 1 over 8 times 1 over 8 times 1 over 8. When we multiply fractions together, we can multiply the numerators together and the denominators together. So I first want to point out that this is the same thing as 1 times 1 times 1, or 1 to the 3rd. And the denominator is 8 times 8 times 8, which is also the same thing as 8 to the 3rd, or 8 cubed. Either way, we need to do 1 over 8 multiplied by itself 3 times. And this comes out to 1 over 512. Take some time to verify these answers yourself. Let's take a look at F. In F, I have negative 2 to the 4th. That is, I need to do negative 2 times negative 2 times negative 2 times negative 2. Keep in mind that 2 negatives multiplied together make a positive. That is, when I multiply these first 2 together, I get positive 4. So I now have positive 4 times negative 2 times negative 2. Well, positive 4 times negative 2 is negative 8. So now we have negative 8 times our last negative 2. Negative 8 times negative 2, 2 negatives make a positive, and I have positive 16. Now look at G. F and G are very much the same, except that F has parentheses and G does not. That means that this isn't negative 2 raised to the 4th power. This is negative 2 to the 4th power. In other words, this is negative 2 times 2 times 2 times 2. Think of the 2 as raised to the 4th power, and the negative is on the outside. Whereas in F, that negative was on the inside and also going to be part of that factor multiplied by itself 4 times. So now I have negative 2 to the 4th. Well, 2 times 2 times 2 times 2 is 16. So this time we have negative 16. It's important that we keep track of those negatives because if you compare F and G, F, the answer is positive 16. G, the answer is negative 16. Let's go on to order of operations. When we are simplifying expressions, it's important that we do it correctly. If we all choose a different order in how we simplify, we're all going to get different answers. So using the correct order of operations will ensure that you get the correct answer. Step 1 is to simplify anything that's inside of parentheses. You might see parentheses, you may see some brackets, you may see absolute value. Any expressions that are inside those, we need to simplify first. Second, we'll go on to exponents. Once we've simplified what's inside of any groupings, we will simplify any exponents that we see and apply those. Third, we'll multiply and divide. Multiplication and division, they're on the same playing field. They have the same priority. So the simplest thing to do is move from left to right in the order that they appear. And lastly, we add and subtract. Addition and subtraction also have the same level of priority. You can move from left to right in the way they appear. One way that many people remember these is by using the acronym PEMDAS, P-E-M-D-A-S. And I'll show you how that's helpful in example 3. In example 3, I'll do some of these and I'll leave some others for you to finish on your own. Let's write down our acronym to help us walk through the steps in the right order. P stands for parentheses, and in example A, we don't have any parentheses, so that's already done. E stands for exponents, and in this example, we do have an exponent. We have 3 to the 4th. So 3 times 3 times 3 times 3 is 81, so we will start by rewriting this as negative 81 instead of negative 3 to the 4th. So now we've simplified any exponents. Next is multiplication and division, moving left to right. The only multiplication that we have is here with negative 2 times positive 7. Negative 2 times positive 7 is negative 14. So we have negative 14 plus 11 minus 81. Last, we have addition and subtraction, and we'll move from left to right. So we have negative 14 plus 11, which gives us negative 3. So now we have negative 3 minus 81. Negative 3, take away another 81, is negative 84. And now we've simplified that using correct order of operations. Let's go on to D. Again, I'll write our acronym, PEMDAS. And we start by simplifying any parentheses. Now we do have parentheses here, but there's nothing inside any of them that need to be simplified. I can't simplify anything about negative 7. Negative 7 is just negative 7. There's nothing to simplify about 3. It's just 3. And also there's nothing to simplify about negative 8. The parentheses in this case are to help us see the exponent, and they stand for multiplication. So let's go on to our exponent step. We do have an exponent with our negative 7 squared. So that's negative 7 times negative 7, which is positive 49. So now we have positive 49 minus 4 times 3 times negative 8. Now let's multiply and divide. We don't have any division, but we do have multiplication. This whole string of items is all multiplied together. We have negative 4 times positive 3 times negative 8. Negative 4 times positive 3 is negative 12. So now we have negative 12 times negative 8, which is a positive 96. So what we have after this step is 49 plus 96. The last step is to add and subtract. We have positive 49 plus a positive 96 for a grand total of 145. Let's go on to part G. In part G, we have quite a bit more going on here. We definitely have some parentheses and some brackets that we need to start by simplifying. The easiest way to think about this is to start from the very inside and work your way out when we're simplifying the parentheses. So the farthest in that our parentheses go is with this 2 minus 8. So I'm going to take care of simplifying what's inside those parentheses first. That is, I'll rewrite this as 4 times 3 squared plus 5, and instead of 2 minus 8, I'll write what 2 minus 8 is, which is negative 6. Now, I still need to simplify what's inside these brackets before I move on. Inside the brackets, I need to use good order of operations. That is, since I've already simplified what's inside the parentheses, I'll move on to exponents inside the brackets. So that 3 squared, I'll write as 3 times 3, or 9. Still working to simplify what's inside the brackets, I'll move on to multiplication and division. I have multiplication with a positive 5 times a negative 6. So I'll write that instead as a negative 30. The last thing is addition and subtraction inside the brackets. I have a positive 9 minus 30, which is negative 21. Now that I've fully simplified the inside of my bracket, I can move on and finish this by doing 4 times negative 21, or negative 84. And that will do it for this section of Chapter 1.